Okay, so today's lesson 5.2, we are focusing on solving right angle triangle problems. So in this problem, in these problems, they are right angle triangles, so we're going to be using SOHCAHTOA, the sine ratio, the cosine ratio, or the tan ratio, depending on what we are given and what we are looking for. All right, so it's not a script that you can essentially use that just says, okay, always use a sine ratio. You always need to think, what do I have and what am I looking for? So let's get right into it. Like I said, it's a short lesson, so it's just two examples. So in this first one right here, the problem is a mountain is 450 meters high. From points A to C, the angles of elevation to the top of the mountain are 70 degrees and 51 degrees as shown below. Calculate the length of the tunnel that runs from A to C. Alright, so we're looking for the length of the tunnel that runs from A to C. So what that means is we're looking for this side length of this triangle right here, okay? If you can picture that big triangle, we need this line green right here. Well, it gives us a few values. So let's go recap what these angles of elevation are of 70 degrees and 51. So imagine you're standing right here and you look at the ground and then you look up at the top of the mountain. That right there would be 70 degrees, okay? And the same thing on this side. It's just saying that like you're standing somewhere, okay? But when you're standing in that somewhere, when you are standing there, you look up, that makes an angle of 51 degrees, all right? Oh, I'm going to erase all that. So we need the green line based off this given information, and this is also how high the mountain is. So if you can see, we actually have two triangles in here, all right? Well, we have two right angle triangles, the first one being what I'm highlighting in blue. So we have created one right angle triangle right here, because that is a vertical line, and that is also 90 degrees right here, all right? And that is a flat line on the bottom. So a vertical line and a horizontal line always meet at 90 degrees. So we have a blue triangle, and you also have this other triangle right here, where I'm now putting it in purple. And notice you have a shared edge right here, this height of this mountain. And the reason I'm highlighting two mountains is because for us to get that total distance that I had in green, which I've now kind of covered, well, you have to think of it as adding up two different side lengths. The total distance is the side length x right here, like this one right here, this side length right here, plus this distance right here, the y. So if I take x and I add y, I would get my total side length AC. All right? And that's our strategy right now. So we are going to be looking for these two values to eventually add them up and get what was our total side length right here. So let's draw some separate triangles here, okay? Always draw visuals. It makes your life so much easier. So I've created this blue triangle where this was 450 meters. This right here was 70 degrees. And we're looking for this x right here. Well, what am I given? I'm just going to move this up actually. Well, what am I given? What am I looking for? Well, I'm given an angle. I'm given the side length that is opposite my angle. And I'm looking for the side length that is adjacent to my angle. So, O and A, TOA. So you're going to be using the tan ratio. Tan of theta is opposite, a side length that's opposite over adjacent. It's a ratio between those side lengths. So let's fill in what we have. Our theta in this case is 70 degrees. The opposite is our given height of the mountain being 450. And the adjacent is the angle, the side length that we're looking for. X in this case. So we need to isolate for this x. What that means is we need to first multiply both sides by x because it's on the denominator. So we need to get it off the bottom of the fraction. So these cancel. And you get x tan 70 is equal to 450 meters. We'll now isolate for x. So you, again, as our recap from yesterday, this tan 70 is a number. It needs to move as one big thing, okay? So do not separate the 70 and the tan from each other. You have to treat it like a number. So you divide it both by tan 70. And now you get x equals 450 over tan 70. And it's just a calculator problem now. You're just taking your calculator and saying 450 divide by, look for that tan button, and type 70 equals. And I get 163, this is a side length, and I'll put it to a decimal because I didn't specify up top, 8 meters. So what that means is what you just found is that going from A to B, like this portion right here, that is 163.8 meters. Now we need this last little bit, the y. We need that last little bit right here, and total is up. So let's draw out that second triangle. The second triangle is like this, where we have it facing this way. I'll connect those. And this is 450. Right here is 51 degrees, and we are looking for this y. So what do we have? What are we looking for? Well, we have an angle. We have the side length that is opposite once again, and we are looking for the side length that is adjacent. So just like the last problem, use the tan ratio. So tan of theta is opposite over adjacent. So tan of our given angle, 51 degrees, is 450 over the value that we're looking for, y. So rearrange this problem, look for y. So first thing you need to do is get it off the bottom. So multiply both sides by y. So these will cancel. Cancel. And you get y tan 51 degrees is equal to 450. And now divide both sides by tan 51, because tan 51 is a number. So it behaves like when you're bringing anything else across an equal sign, any other number across an equal sign. So these cancel, and you get y is equal to 450 over tan 51. And use your calculator, so 450 divided by tan 51, you get y is equal to 364.4 meters. All right, so you found this distance right here to be 364.4 meters. So the combination of your two values, these and these right here, is going to give you what you want, the total distance going from A to C, okay? So A to C, and just so when we talk about side lengths of a triangle and we are describing it by its vertex, so like vertices, so there's vertex A, vertex C, we call a side length like this with a line over it. So that's side length AC. And that is equal to the value x that we found plus the value y we found, which was 163.8 plus 364.4. Add those two together, so plus 163.8, and you get 528.2 meters. So therefore, side length AC, which was in the context of this problem, was the tunnel length. So the tunnel length is 528.2 meters. And there we go. So let's try example 2. Given the figure below, side length EG equals 77.2 meters. Angle E, which is part of triangle GEF. Okay, so the way you read this is I'm saying an angle, and it's part of the triangle GEF. And the angle being given is the letter that you see on the inside here, okay? So it's actually angle E from the triangle GEF. So here's G, F, and E. So those represent the vertex of our bigger triangle right up here and here. So this side length is, or sorry, that angle, not side length, this angle is the 56 degrees that's being given. And I guess while we're at it, let's fill in this. EG being 7.2, that's this side length right here, 7.2. And then angle, okay, so again, you're given an angle, GEF, so the angle being given is angle E, but in this case, it's part of the triangle G, E, and H. So G is right here, H is up here, so now it's this triangle, this smaller one with my yellow dots. So if you were to draw a triangle, you can see it'd be like this right here, right? So that angle is 41 degrees. So this one right here is 41 degrees, the smaller one. And actually, I'll put it on the inside so you can see it's smaller. 41 degrees, okay? Determine the area of triangle EFH. Round your answer to the nearest tenth of a square meter. All right, so we're looking for the area of triangle E, F, and H. So that's this triangle here, here, and here. So that'd be like this right here, what I'm drawing out. Well, first, let's cover, what is the area of a triangle? Area of a triangle is base times height divided by 2. Well, when we're doing base and height, we need values that are flat and straight up and down. Okay, so like you need a value that's up like this. So this would be like your height, this would be your base. So you'd find those two values, divide it by 2 to get the area, which is the total space that this occupies. Well, let's look at what I've drawn in blue. Can you see how this side length right here is not really flat? It's kind of on an angle. We don't really have a clean height, okay? So really what we need to do to find this shaded blue area here, okay, like that's our goal. Well, what we need to first do is we need to find the area of the big triangle, okay? So let's, like the big triangle being this one, I'll draw it out for you. Big triangle being F, G, and E, okay? And inside of that big triangle, we have the area we are looking for, which is this right here. So if we can find the area of the big triangle and then subtract away this yellow chunk right here, the smaller triangle, H, right, HE, this one right here. If we can subtract this away, so if we can take triangle area of F, E, G, EFH, sorry. Yeah, well, FEG. And then if we can subtract the area of H, E, G, we would get the blue area. This would equal the blue area, like this one right here. That would give us the area E, F, H. And by the way, it really doesn't matter what order you put these in, okay? It really doesn't matter. The only time it matters is when you're specifying the angle right here, because then you read the triangle that, oh, okay, the thing that's on the inside corresponds to that right there. Otherwise, it really doesn't matter how you put those. So this is the big area. This is the little. And then this is what we want. This is the leftover. And this is what we're after, like that right there, okay? So we're just about to do some math, but like just don't get lost in the weeds of what we're about to do. Like this is the process. We're just going to find big area, subtract little area, and we're going to get what's left over, and that's going to be your answer. So in order to do that, in order to find these areas, we need to go back to our area formula and we need some side lengths, okay? So let's first deal with the big triangle. So let's get our big area. And that is the triangle FEG. So FEG. And we have this angle right here being 51 degrees. And we have this side length right here being 7.2. So in our formula, really look, compare it to this over here. Well, this 7.2 represents our base. So what we need is we need this side length right here. We need our height. That's what we're looking for to be able to get this area. So what do we have? What are we looking for? Well, we have an angle. We have the side length that is adjacent to it. And then we are looking for the side length that is opposite. So in doing this, we are going to use the tan ratio again. So tan of 51 degrees, all right, or I'll just write out the formula, tan theta is opposite over adjacent. So we are looking for this, and let's give it a variable. So let's say this side length right here, let's call it y. All right, so we're looking for y. Tan of 51 degrees is y over the 7.2. So we're isolating for y. So get rid of the 7.2, so multiply both sides by 7.2. 7.2. Give me one sec, actually, I just need to turn the light on. It's pretty dark in here and I can't see my calculator. Okay, so we are looking for y. So we need to, now these will cancel. And you get 7.2 tan 51 degrees is equal to y. So tan 51 times 7.2, I get a y that is 8.89 meters. So this is 8.89 meters. Or you can round, I went to 2 in this case. So let's find the area. We now have our height. That y was the height of our triangle. So the area of this big area, like this area of the big triangle, is base times height over 2. So in this case, we have a base of 7.2. We have a height of 8.89, and divide those by 2. And you get a big area. So 7.2 times 8.89 divide by 2. We get 32. And it wants to go to the nearest tenth of a square meter. So actually it just ends up being 32 meters squared. Okay, there is the big area. Let's get the little one, the smaller triangle. All right, so let's give ourselves some room. So we now have the triangle EHG, or HEG, where this was the vertex H, this was the vertex E, and this is the vertex G. And we were given an angle of 41 degrees. This was a side length 7.2. And let's give what we're looking for a variable, x, okay? Because this is essentially our base, and x represents our height. So we need both of those variables, base and height, divided by 2 to be able to get our area. So let's look for x. That x, based off what we're given, is our opposite side length. So this is our opposite. And we are given an adjacent. So tan ratio. So tan theta is equal to opposite over adjacent. So tan of our given angle 41 degrees is x over 7.2. isolate for that x. So multiply both sides by 7.2. You get 7.2 tan theta, tan 41 degrees, is equal to x. So 7.2 times tan 41, I get an x value of 6.26 meters. So let's calculate our area. Our area is the base, 7.2, multiplied by that height we just found, 6.26, and then divided by 2. So in doing that, times this by 7.2, divided by 2, I get an area of 22.5 meters. So the big problem was us taking our area of the big triangle minus, so instead of writing out all those triangles, why don't we just call this A1? We'll call this A2. So we have A1 subtracting A2, and that's going to give us our answer, the area of triangle. And this one I am going to write out just because it asks for it, EFH. So area EFH. So we have the first area being 32 meters squared, 32 meters squared, subtracting our other one, which was 22.5 meters squared. So we get an area 32 minus 22.5 of 9.5 meters squared. So therefore, the area of triangle EFH is 9.5 meters squared. Okay, so like I said, it was a short lesson today. All right, I know a lot of it was using the tan ratio, but you can use all different types, and you will see these in the homework, okay? So I'll see you in class. Bye for now.